In this video, we're going to move on and try to factor polynomials. So in the last lesson, we learned how to divide polynomials through long division or synthetic division. So here I have an example of long division from last lesson. And when we divide 2x squared minus 5x minus 1 by x minus 3, we will get the quotient at the top. So this is your quotient. And then the number that stands alone at the very bottom is our remainder. So the remainder is 2 in this case. If all we want to do is actually just find the remainder and we don't care about the quotients, we can use the factor theorem. So the factor theorem states when a polynomial p of x is divided by a binomial, the remainder is p of a. Now here's an example, numerical example, where we don't need to divide by x minus 3. We just want to calculate f of 3. And I'm using the same polynomial up here and the same divisor of x minus 3. So what we do is we plug in x equals 3 into our polynomial of 2x squared minus 5x minus 1. So that's where this is coming from. And then you simplify after that, and the number that you get is actually your remainder. So let's try this with an example. Example 1. So we just want to find out the remainder when this large polynomial is divided by x minus 1. So that means that I'm going to plug in x equals 1 into our polynomial, and I'll call this polynomial p of x. So what we want to calculate is p of 1. Then I'm going to plug in 1 into each x value. So this will become 3, 1 to the power of 4, plus 7 times 1 to the power of 3, minus 1 squared, plus 14 times 1, minus 3. And then we would simplify this. Try not to use a calculator, even though it's very tempting to. The provincial exam will make you do this as mental math. There's only certain questions on the provincial exam that they're actually going to let you use a calculator, and this one is not it. So you do need to exercise your mental math quite a bit in this course. So 3 times 1 is 3, 7 times 1 is 7, 1 squared is 1, 14 times 1 is 14, and then negative 3 is still there. So 3 plus 7 is 20, then minus 1 plus 14 minus 3, all this together would be 20, so that means your remainder is 20. And we'll do another example. So in this case, we're going to plug in x equals minus 3 into our polynomial. So we're calculating p of negative 3. So 3 times, according to our polynomial up here, I'm just putting in negative 3 wherever I see an x. So you have negative 3 to the power of 4 plus 7 times negative 3 cubed minus negative 3 squared plus 14 times negative 3 and then minus 3. So negative 3 to the power of 4, that's positive 81. Negative 3 cubed is negative 27. Negative 3 squared is 9. 14 times negative 3 is negative 42. 3 times 81 is 243. 7 times negative 27 is negative 189. And then we would subtract from left to right, and we would end up with 0. This means that we get a remainder of 0 when we divide by x plus 3. So when you divide by x plus 3, we divide by the p of x with p of x, and we would get a remainder of 0. It's divided evenly. For example 2, we want to know which binomials are factors of x cubed plus 2x squared minus 13x plus 10. So we know a binomial is a factor when the remainder is 0. So if we use our factor theorem and we found out that it is 0, that means that that binomial is a factor of our polynomial. So I'm going to call this x cubed plus 2x squared minus 13x plus 10 as our p of x. And I'm going to plug x equals 1 into p of x and see what remainder I get. So if it is 0, then I know that x minus 1 is a factor of our polynomial. If I get any other number besides 0, then it is not a factor. So we have 1 cubed plus 2 times 1 squared minus 13 times 1 plus 10. So again, I'm just plugging 1 every place where I see an x. So if you simplify this, we will get 0. So that means x minus 1 is a factor of p of x. I'll do one more with you, and then I want you to try C and D on your own. So we're going to plug in x equals 2 here into p. So we're going to calculate p of 2. That's 2 cubed plus 2 times 2 squared minus 13 times 2 plus 10. Which is 8 plus 8 minus 26 plus 10. This again is 0. So that means x minus 2 is a factor. So do the same sort of thing for C and D. If you get a remainder of 0, you know it's a factor. If you don't get a remainder of 0, you get any other number, that means it is not a factor. So go ahead and try that, and when you are ready, press play for the solution. So here is this following solution for C and D. If you plug in p of negative 2, you're going to get 36 as your remainder. So that means x plus 2 is not a factor of p of x. If you put in p of negative 5 and calculate that, you will get a remainder of 0, which means x plus 5 is a factor. Moving on to example 3, we're going to factor a polynomial now, and we will use our synthetic division to do that. So to figure out what factor you're going to use, you're going to have to do a bit of guess and check. So I'm going to set up our synthetic division just like our lesson last time. I'm going to put the coefficients at the front. I want to bring down that 2. Now this number in here is going to be the guess and check. You can start with doing plus and minus 1 and then plus and minus 2 and then going forward from that, but usually it will be some sort of factor from 6. So we can divide 6 by 1, 2, and 3, but we can't divide by 4, so I wouldn't want to put a 4 in there. So I'm just going to let you know that 2 is going to work out. Could have also picked 3 and that would work out as well. But again, it is guess and check, so if 1 didn't work and you didn't get a remainder of 0 at the end, then you just try a different number. So I brought down the 2, I'm going to multiply it with the 2 in the corner here, which is 4. Then add negative 9 and 4, which is negative 5. Multiply this negative 5 with the 2 in the corner here, so that is negative 10. Then I want to combine the 7 and the negative 10, which is negative 3. Multiply negative 3 and 2, it's negative 6. Add them together, it's 0. So we learned how to write this out as a polynomial. These are your coefficients. And then for your powers, it's going to be 1 less than what you started with. So this will be 2x squared minus 5x minus 3. Now don't forget your 0 of 2. This says that your factor is x minus 2. Then we can continue to factor because 2x squared minus 5x minus 3 is factorable. And you can use your box method to do that. So you have 2 and 1, and factors of 3 are 1 and 3, so we had to use that. Cross multiply, you got 6 and 1, and we can create a negative 5 with that if you had a negative 6 and a positive 1. So I'm going to include this in my bracket of 2x plus 1, and the other one's going to be x minus 3. And that is our final answer. So if you have a power of 3, make sure you have 3 factors multiplying with each other. I want you to try it yourself on the next page. Please change that 4 to a 3. That's a little typo there. And then go ahead and try to factor that using synthetic division. All right, so here is the solution to that. Try it yourself. You can pick a negative 1. You could have also picked 2 and it worked out. You're going to get different numbers than me, of course, if you pick 2. But if you pick negative 1, this is what it's going to look like. So you bring down the 3, multiply with the negative 1 to get negative 3, combine your negative 4 and your negative 3 together to get negative 7, and you just continue that process until you get a remainder of 0. So remember, if you don't get a remainder of 0, then you have to try again and pick a different number for your corner. Okay, so remember to put in the minus 1, 0 as your factor of x plus 1, and then rewrite your polynomial out. And to start with 1 exponent less than what you have, so that's why I have 3x squared minus 7x plus 2. And then you can factor that again, and this will be your final answer. Okay, so for your last example, we're going to work a bit backwards here. In this case, we're given a polynomial, but we're missing a coefficient. We also know that if we divide by x plus 1, the remainder is 8, and we want to determine this coefficient. So we can use the factor theorem here. Okay, so what it's saying by divided by x plus 1, the remainder is 8, that means if I plug in x equals 1 into this polynomial, I will get back 8 as my remainder. So in other words, p of 1 is equal to 8. Now, our polynomial is given to us already is 2x cubed plus kx squared minus 5x plus 1. But my x value is 1, so I'm going to plug in 1 into here on the left-hand side. And then I'm going to simplify everything and then try to isolate k so I can solve for it. Okay, so I have 2 minus 5 plus 1, that's 4. And then I'll subtract 4 on both sides. So my final answer is 4 for k. So that's it for this lesson. Please check what is assigned for you for your homework.